Hello everyone, welcome back. In this video, we're going to look at differentiation rules when we're dealing with the multiplication or division of functions. And these are called the product and quotient rules respectively. So the product rule says is that if we have two functions f and g, which are both differentiable, then the derivative of f of x times g of x is equal to g of x times the derivative of f plus f of x times the derivative of g. So we differentiate each function separately, and then we multiply it by the other function, and then we add these two results together. Now the quotient rule says is that if we have f and g, which are both differentiable, then the derivative of f of x divided by g of x is given by this formula. We have g of x times the derivative of f minus f times the derivative of g, all divided by g squared. So we can also write these rules using prime notation. So the product rule says that if we want the derivative of f times g, this is equal to f prime times g plus f times g prime. And for the quotient rule, we have the derivative of f divided by g, and this is equal to f prime times g minus f times g prime, all divided by g squared. So let's have a look at some examples of using these rules. So for the first example, we have x cubed minus 2x times x to the negative 4 plus x to the negative 2. So here we can look at the first set of brackets as one function. We'll call this f. And this is being multiplied by the second set of brackets, and this is what we'll call g. So here we will apply the product rule. So the derivative of this function is going to be f prime times g plus f times g prime. So the product rule says we differentiate our f, which is x cubed minus 2x. So the derivative of x cubed, if we use the power rule, is 3x squared. The derivative of negative 2x is negative 2. So that is our f prime. And this is multiplied by g, which is x to the negative 4 plus x to the negative 2. And then we add this to f times g prime. So our f is x cubed minus 2x, and this is multiplied by g prime, and so we have negative 4 times x to the negative 5 minus 2x to the negative 3. So we multiply the exponents in front and then subtract 1 from the exponents. And so the derivative of f of x is given by this formula. In the next example, we have f is x to the 1/3 minus 2x to the negative 1/2 multiplied by x squared minus 4x plus x to the negative 1. So again, we have two functions being multiplied. So we will call x to the 1/3 minus 2x to the negative 1/2 as our f, and x squared minus 4x plus x to the negative 1 is our g. So again, we apply the product rule. So f prime times g plus f times g prime So the derivative of f is 1/3 x to the negative 2/3 minus 2 times the derivative of x to the negative 1 is negative 1/2 times x to the negative 3/2. So this is our f prime. This will be multiplied by g, which is x squared minus 4x plus x to the negative 1. And then we add this to f, which is x to the 1/3 minus 2x to the negative 1/2. And we multiply this by g prime. So we need the derivative of g. So the derivative of x squared is 2x. The derivative of negative 4x is negative 4. And the derivative of x to the negative 1 is negative 1 times x to the negative 2. In the next example, we have the reciprocal function, which is 1 over x. So we know from the previous few videos that the derivative was negative 1 over x squared. So we're going to apply the quotient rule to obtain the same derivative formula that we have earlier. So 1 over x, so we have the division of two functions. So we will apply the quotient rule. So the numerator is going to be our f, the denominator is going to be our g. So the derivative of this function using the quotient rule is going to be f prime times g minus f times g prime, all divided by g squared. So we need f prime. So the derivative of 1, we know that the derivative of a constant is 0. So f prime will be 0. We multiply that by g, which is x. We then subtract f, which is 1, times g prime, so the derivative of x, which we know to be 1, and this is all divided by g squared, so that is x squared. And now this can be simplified to negative 1 over x squared. So in the next example, we have another rational function. So we have x squared plus x minus 2 all over x cubed plus 6. So we're going to apply the quotient rule. So the numerator is our f, the denominator is our g. So the derivative of f, again, is f prime times g minus f times g prime all over g squared. So we need the derivative of f. So the derivative of x squared plus x minus 2, which is 2x plus 1 minus 0. This is all being multiplied by g, which is x cubed plus 6. And then we subtract f, which is x squared plus x minus 2. And then we multiply this by g prime. So the derivative of g, which is 3 x squared plus 0. So we don't have to write the plus 0 at the end. And then this is all divided by g squared. So that is x cubed plus 6 squared. And here we can just leave our derivative without simplifying. Later on, it may be useful to simplify our derivatives, but for now, we'll just focus on applying the rules. So in the next example, we have x squared minus 2 over 2x plus 1. So again, we apply the quotient rule. So x squared minus 2 is our f, and 2x plus 1 is our g. So the quotient rule says we differentiate our f, which is 2x. We multiply this by g, which is 2x plus 1. We then subtract f, which is x squared minus 2, and then multiply that by the derivative of g, which is 2. And this is all over 2x plus 1 squared. In the next example, we have the root of x over 2 plus x. So let's first rewrite the square root as an exponent. That's x to the negative 1/2. That's all over 2 plus x. Oops. And once again, we have the quotient rule. So the derivative is going to be f prime times g. So the derivative of x to the 1/2 is x, or 1/2 times x to the negative 1/2 multiplied by g. So that's 2 plus x. We then subtract f, which is x to the 1/2, times the derivative of g, which is 1. And that's all over 2 plus x squared. In the next example, we have x to the 4 minus 5x cubed plus x to the 1/2 all over x squared. So this can be written as x to the 4 minus 5 times x cubed plus x to the 1/2. This is all over x squared. And we once again apply the quotient rule. So f prime of x is going to be the derivative of the numerator, which is 4x cubed minus 15 times x squared plus 1/2 x to the negative 1/2. This is multiplied by g, which is x squared. And then we subtract f, which is x to the 4 minus 5x cubed plus x to the 1/2, and this is multiplied by the derivative of g, which is 2x. This is all divided by the denominator squared, so that is x squared squared. In the next example, we have x to the 4 minus 1 divided by x to the 4 plus 1. So let's apply the quotient rule. So the derivative is going to be 4x cubed times x to the 4 plus 1 minus x to the 4 plus 1 times 4x cubed, and this is all over x to the 4 plus 1 squared. And the last example, we have x plus 1 times 1 over x minus 1. So let's look at rewriting 1 over x as a negative power. So this is x plus 1 times x to the negative 1 minus 1. So here we will apply the product rule. So x plus 1 is our f, x to the negative 1 minus 1 is our g. And so the product rule says we differentiate f, which is 1, multiply it by g, which is x to the negative 1 minus 1, and then we add it to f, which is x plus 1, times the derivative of g, which is negative 1 times x to the negative 2 plus 0. And we don't have to write the plus 0.